Okay, this is the second part of Circles Lesson 3, the last section, and these big circle puzzles are kind of fun. They use all of your circle formulas and theorems kind of all at once. There is a typo on this page. I'm sorry for that. When I talk about the tangent lines, I'm talking about line FD. I mean FB. So please fix this. It should be FB and point B here as well. So sorry about that, but it shouldn't be too detrimental to your work. All right, let's look at part A. It's asking us for the measure of angle BFC. So B to F to C would be this angle. Now, a lot of us assume that this is 90 degrees. And in this case, you are assuming correct, but I want to make sure you understand why this is 90 degrees. First off, I see this line is a radius, and it is meeting with this line, which is a tangent, at the point of tangency B. So that means, based on our radius tangent theorem, that must be a 90-degree angle. The same thing is going on here. I have a radius meeting up with a tangent, so I have another 90-degree angle. So therefore, I have a closed figure with 390 degrees. It is a four-sided figure, so it all must add up to 360. So that one must be 90 as well. Bonus, I also know that this must be a square, because this guy and this guy are both radii. I mean, they come from the center, go to the edge. So if they're both radii, they must both be congruent. So this must be congruent to that. I have 4 congruent sides and 4 right angles, so I know I have a square. In other words, I know that the measure of angle BFC is 90 degrees. Which leads us to the next one, angle CBF. From C to B to F would be right here. So this portion of that angle would just be 45 degrees. So let's take a look at angle DRC. Measure of angle D to R to C, that's right here. Well, I see that those two angles together form a straight line. So angle DRC would just be 180 degrees minus the 83 that is already there. So that gives me an angle of 97 degrees for angle DRC. Okay, next I'm looking for the arc measure from A to B, the measure from arc A to B. A to B would be this little arc right here. Remember that an arc measure comes from its central angle. So if I trace this guy's lines back, I see that it comes from the central angle coming from O out to A and B. In other words, if I could find this little sliver of an angle, it would be the same as this squiggly arc out here. So using the same idea as we just did for part C, I see that I have a straight line made up of these 3 different angles. So that means that that little tiny sliver there, I could find it by just doing that 180 minus the 78 and the 90 that are there. That leaves me with 12. That little baby angle is 12, so that means this arc is 12. Next, I'm finding the angle DPC. Let's go ahead and trace that. From D, tracing it in yellow for us, from D all the way down to P, and then back to C. This guy looks like his angle or his vertex is outside the circle. So that means I'm going to use that idea that where the angle equals the big arc minus the little arc divided by 2. So we have to think about where are the arcs on this within this yellow angle. I already know the little arc, that was the one we just found, that's 12. The big arc, I think, would be from D all the way to C. So I need to figure out what that arc measure is, this guy, because then I can just do this guy minus this guy divided by 2, and I have the yellow angle that I want. Where a lot of students mess up here is they say that this big blue arc is 97 degrees because they see this angle and they're like, oh yeah, it's just the same. You have to be really careful though, because that is only true if that angle is in the center of the circle. In this case, this guy is not in the center, so this is not the same. Instead, I see that that blue squiggly comes from the center using the angle of 78 degrees. So be really careful here. The actual central angle that opens up to this blue arc is 78 degrees, not 97. Now that I know that, solving for this angle down here will be pretty easy. The big arc of 78 minus the little of 12 divided by 2. So my angle is going to equal 78 minus 12 divided by 2. Well, 78 minus 12 gives me 66 degrees. If I divide that by 2, I have 33 degrees for angle P. Next, I'm finding the arc measure from E to D. So that would be from E to D right here. Let's go ahead and trace where that arc comes from, which angle. So I'm going to trace his lines back to a vertex, and I see that these lines meet at vertex R right there. So that makes me think that this is one of those problems where the vertex is inside the circle but not on the center. So usually these problems look like they have X's, so I'm just going to continue to trace these lines all the way through until I have a nice looking X that I can work with. All right, there we go. So again, I'm working with the idea where the vertex is inside the circle, but not on the center. So this is the idea where the angle is going to equal the big arc plus the little arc divided by 2. Remember here that I'm solving for this arc, which I think in this case will be the little arc. I'm going to call that X. I have the angle, and I need to know what the big arc is. So if you look at our yellow X, the big arc would be the place where the yellow X gets connected using the edge of the circle. So I'm going to signify that with this purple. If you notice, the purple arc, the big arc, goes all the way from C all the way to A. So I will need to know this arc, the angle, and the angle to be able to find that arc. Okay, so what would this purple arc be? I see a central angle that might be able to help us, or I also see a diameter. There's a couple different ways you can solve this. I think the easiest is probably the diameter. It says in the direction that D to A, or this yellow line right here, is a diameter. So doesn't that mean that the red plus the purple must equal 180? Well, if the red is 78, then the purple must be 180 minus 78, or 102 degrees. Again, I got that purple by doing that idea that a diameter separates a circle into 180 degrees. I already used 78 of them, so the purple is the leftover. So 180 minus that 78 gives me that purple is 102 degrees. All right, then I think I have enough information to go ahead and solve using our formula. Again, I know the angle. It's 83 degrees. That's the angle inside the circle, but not on the center. That 83 equals that big arc, that purple arc of 102, plus the little arc of X divided by 2. I don't want that X to be divided by 2, so I'm going to start by timesing by 2 on both sides. And I get 102 equals 83 times 2 gives me 166. And then, I'm sorry, I forgot my 102 plus X. There we go. So these guys cancel. I have this left over. All right, and then I'm ready to go ahead and get my X by itself, so I can subtract 102 from both sides. And 166 minus 102 gives me my x is 64 degrees. So that yellow arc out there is 64 degrees. Last but not least, I need to find the measure of arc EA. So that would be the distance, or I'm sorry, the degrees, the amount of degrees from E all the way through M and to A. Remember one more time that we have a diameter. I know that the line from D all the way through A, according to the directions, is a diameter. So doesn't that mean that all the way from here all the way around would be half the circle, or 180 degrees? Well, we just used 64 degrees to get that yellow arc, so the leftover would be the green. To find that green arc, I just need to do 180 minus that 64, and we get the green arc is 116 degrees. There you have it. Okay, last one. Let's take a look at circle P. We have a radius of 10 degrees, or of 10. So before I start, I'm going to label all of my radii. I'm going to label this radius here of 10. P to C is a radius, and so is P to D. P to B is a radius as well, but I'm going to skip labeling it because you'll see later that it actually doesn't need to be labeled. I also know that AC is a chord and it's perpendicular to this diameter marked right here, which one of our theorems states that if you have a radius or a diameter perpendicular to a chord, you must have two congruent pieces of that chord. In other words, this is the perpendicular bisector of that chord. Finally, I know the measure of this arc from C to D is 150 degrees. Remember that a measure of an arc comes from the measure of the central angle. So that means this central angle must also be 150 degrees. Okay? Finally, I can add some more information. If that's 150 degrees, I can kind of finish that straight line and say that this must then be 30 degrees, so that together it gives me 180. And that means that this guy must be 60 degrees because it makes up a 30, 60, 90 right triangle. Let's see if that's enough information to get us started on part A, the length of arc CD. Be careful. The length of arc CD, I'm asking for a length, not a measurement. So I am not asking for how many degrees this is. I'm asking for an actual length, like in centimeters or inches. This is one where we have to use a formula. To find the length, an arc length, our formula is the central angle divided by 360. In other words, the fraction of the picture we're covering, and then times by the circumference. So that's times by radius times 2 times pi. If we can solve that, we'll have the arc length. So let's go after arc length of this. So his central angle must be 150. I'll put that over 360 and times by my radius, which is 10, times that by 2 and stick a pi with it. Let's go ahead and reduce that 150 and 360. I'll divide both the top and the bottom both by 30. And that will give me 5 over 12 times, looks like 20 pi. Then I can multiply straight across and I get 100 pi over 12. Before circling my final answer, I see that both of these numbers are divisible by 4, which gives me an answer, a final reduced answer of 25 pi over 3. So that means that the length of arc CD is 25 pi over 3, and you could put U for units since we don't know if it's inches or centimeters or whatever. The next one finds the length of arc AB. So let's look at where that's at. A to B is here. He currently does not have a central angle. There is no central angle that comes like from P to create that line or to create that arc. So we can draw one in, however. If I draw this black line from A to P, I just basically put in another radius because I went from P, the center, to the edge. Wait. If I just drew another radius, wouldn't that length then be 10? And wouldn't this guy have to be a 90 degree because those together have to be 180? So isn't this triangle congruent to this triangle? In other words, this guy is also 30 degrees and that other one is also 60 degrees. Oh, so I have like a completely symmetric triangle or completely symmetric other half of the circle going on here. I mean, you can basically copy like this whole thing down. So let's go after the arc length from A to B now that we know that the central angle creating that arc coming from the center P is 30 degrees. We're going to run the same formula that we just did, but now we're working with the central angle of 30 degrees. So my central angle is 30 degrees over 360 times radius, which is 10 times 2 times pi. Again, I'm just using the same formula that I used above. Let's reduce that 30 over 360. I'm going to divide both by 30. And on the top, I get 1, and on the bottom, I have 12. Then I can times that by 20 times, because 10 times 2 is 20, so 20 pi. And I'm ready to multiply straight across, which gives me 20 pi over 12, and those are both divisible by 4. So I have 5 pi over 3. So the length of that arc is 5 pi over 3 units. Next, I'm finding the area of the sector. So this one also has its own formula. Let's look at the sector APC. That is basically going from A to P all the way to C. That would be this entire slice of pizza. I want to know what is the area of this pink wedge of pizza. So I'm using my formula where an area of a sector, my area of a sector equals my central angle over 360, because again, we're only using a fraction of the circle, times by the area formula for a circle. So radius squared times pi. So let's apply that to this problem. What is my central angle? Well, remember, it's this whole thing, so it must be 60. So 60, my central angle over 360 times my radius, which is 10 squared times pi. So if I was to go ahead and reduce, I can divide both the top and the bottom by 60, and I would get 1 over 6 times 100 pi. Multiplying straight across would give me 100 pi over 6, but both of those are divisible by 2. So that would give me 50 pi over 3. The answer for part C is 50 pi over 3 units squared, because we just found area. All right. The next two are asking for length. If I don't have a measurement sign out front, I'm asking for the length. So how long is the line from A to M? Let's go up to the picture and look for A to M. Oh, I see. That is this line, which is, of course, congruent to his brother over here. All right. Well, to find A to M, I think we're going to have to utilize the fact that this is a 30, 60, 90 right triangle. Let me just take this triangle and draw it again so we can play with him a little bit. Let's go down here. Basically, inside of that circle, remember, we have this triangle going on. We have point A, point M, and point P. I know that this is a right angle. I have that congruent side. And I know that this is a 30-degree angle and this is a 60-degree angle. Even if it doesn't look like those angles are in the right place, just go by the math, not by what the picture looks like. Finally, I know that from A to P is a radius, so it must be 10 units long. In general, a 30, 60, 90 right triangle follows these rules. The side across from 30 is x, the side across from the 90 or the hypotenuse is 2x, and the side across from the 60 is x root 3. So looking at this picture, it looks like I have information about the hypotenuse side. So I'm here. To go from the hypotenuse side to the side across from 30, to go from the hypotenuse to the side across from 30, so from here to the side across from 30, which would be here, I have to divide by 2. So that means that A to M must be 5, because I just have to divide by 2. So my answer for A to M is 5. If I kept going on this circle from I'm now here and I know that this is 5, to get to the side across from 60, or in other words this spot, I'd have to take that number and times it by root 3. So that means this side must be 5 root 3. Let's add that to our picture and keep in mind our next question asks us to find the length of MD. I know now that this side is 5, which means this side is 5, and I also know that the little short side is 5 root 3. Again, my picture is a little bit off according to my numbers, but please just go by what the numbers say. Okay, I know that this little short side is 5 root 3, and my next question asks me to find the length from M to D. Well, wouldn't that just be that 5 root 3 plus a radius length of 10? So 10 plus 5 root 3. Now, be very careful. It's tempting to say that this answer is 15 root 3, but remember we can't add these things together because we do not have like terms, so you can just leave your answer like that. You could, if you want, type this into your calculator and get a decimal version, but why would you if you don't have to? You can totally leave it like that.